Okay. So again, we are in 3.2. This is section 3.2. And we're looking at finding the domain of a function. So how do you find, what does it mean, by the way? Let's talk about what this even means. Domain is all x values that are allowed or possible, however you want to say it. So for example, that might seem confusing. Let me give you a real life example. So the domain, I always use a toaster. The domain of a toaster, I always use a toaster as my function comparison. The domain of a toaster would be things you are allowed to plug in to the toaster. Well, to plug to, not plug in, that sounds like you're plugging in. Things you're allowed to put into the toaster. So domain is, I said it's the X values, and the X values are what we plug in, aren't they? So that's why I'm making that analogy for you. The domain of a toaster. So what would be in the domain of the toaster? Well, it's whatever you're allowed to put in. So you can put in bread, you can put in frozen waffles, etc. Not knives. You shouldn't put knives into the toaster. You could get yourself electrocuted or something, I suppose, right? So you get the idea. Domain is things that you're allowed, X values that you're allowed to plug in. So for a toaster, it'd be, what you can put in a toaster. For a function like this one, it's what you're allowed to plug in for X. So X, remember, the X in a function is like the holes in a toaster. It's the insert slot. It's where you plug stuff in. Okay, so you're probably like, all right, I got it, Mr. I got it. So let me ask you, we know, you're not supposed to put knives in a toaster. Get right, of course, obvious. So, or like you have a microwave oven, you're not supposed to put in metal because it'll spark. So what about this function? What can you not put in for X? I mean, couldn't you just put anything in? What number would be a problem for, at least for my function? Do you see it? Do you see a number that would be a problem? What if I put in a 9 for X, just like the other 9 that's next to it? Would that be a problem? Yes, it would, because that would be 6 over 9 minus 9, which is 6 over 0. And I don't know if you know, you can try it on your calculator. 6 over 0 is actually, it's infinity, really. Your calculator will tell you error. You can't divide by 0. Why not? Because 0 in the bottom of a fraction is actually infinity. Let me prove that to you. If you take 10 divided by 2, you know the answer is 5. Why? Because 2 goes into 10 5 times. So if you take 10 and divide by 0, how many, doing the same thinking, how many times does 0 go into 10? How many times does 0 go into 10? It goes in forever, doesn't it? Infinite. So that's why we say error, or we say does not exist, because you cannot divide by 0. You can't do it. It goes in infinitely. It's not a number. You can have 0 in the top of a fraction. That's no problem. That's just 0, right? Why? Because a fraction means the bottom into the top. That's the very meaning of a fraction. So how many times does 10 go into 0? Well, 0 times, no problem. But this is what you can't have. This is the big no-no. You can't have 0 in the bottom. So we never have 0 in the denominator. It's a big no-no. It equals infinity or error. It's not a number. You can't do it. Just give you error in your calculator. Okay, great, got it. So that means you can put anything you want in there for x. Any number in the whole world you want to put in, but not 9. Anything but 9. You can put in 10, 11, 12, 9.3, negative 10 million. Great, fine, do it. Just don't put in 9, because that'll make the bottom 0, and that's dividing by 0, and that's infinity. So that's why the correct answer is right here. What does this say? This is what's called set builder notation. Don't worry about it. I'm not going to quiz you a lot of it, but basically it says the set of all x such that straight line. You go higher in math after calculus, you prove things. Anyway, the straight line actually is shorthand for the word such that. In higher math, they have shorthand symbols. Anyway, you don't care. I'm not going to test you on it. Don't worry. That straight line means such that. So this says all x is such that. This is all you really care about. In fact, don't even worry about those stuff. Just look right here. X cannot equal 9. X can be anything except it cannot equal 9. Anything but 9. Not 9, but anything else. Can be 8, can be 7, can be 10, can be 12, whatever, but not 9. So that's the domain. That's what you're allowed to plug anything you want into this function, but not 9. Now, I gave you this in the notes. Here's the exam 1 notes. This is at the top of the Unit 1 module in your Canvas course shell. Exam 1 notes. So here it is. And notice I give you the instructions here. I say, first off, to find the domain, take the denominator, set it not equal to 0, and solve for x. I give an example. Take that denominator, set it not equal to 0, and then solve for x. So that's basically what we would do on this problem. So to do this problem without all this talk, I would just say, okay, get rid of all this. I wanted to explain it slowly to you, but here's all you would really have to do. You would just grab this denominator. You say, all right, denominator, you cannot equal 0. All right, denominators cannot be 0 because that'll be infinity when we divide by 0. And then you just solve for it. Add 9 to both sides. This is actually a not equals equation, which is kind of funny. So x not equal to 9, which is what we already said, is the domain. That tells us that we can plug anything we want in, but not 9. That's called the domain. The domain is what you're allowed to do. You're allowed to do anything, but not 9. X cannot be 9.